Okay, so in today's video, we're going to be talking about physical and chemical properties and changes. So if you were asked to describe a substance, okay, what would you describe about it? Well, here's a few things. Oh, I'm getting ahead of myself here. Okay, so back up. Here's our goals for this section, all right? So forget what I just said. So we're going to try to distinguish between physical and chemical properties at both the particulate level and the macroscopic level. Getting ahead of myself, getting too excited here. And then distinguish between physical and chemical changes, okay, at both the particulate and macroscopic level. Now, what I was saying was, if you were going to describe a state of matter, or you were going to describe a substance, what would you say about it? Okay, well, there's a few things that you might say. You might talk about its color. So this is sulfur. Okay, so it has this yellow color. Right, so you might describe its color. You might describe its smell. Okay, so I think this little kid has those personal pan pizzas from maybe Pizza Hut. It looks pretty good, but you might, he seems to definitely be enjoying this, but you might describe its smell. And just for the record, sulfur smells terrible. So, you know, if you can avoid it, definitely do. It smells like rotten eggs. But so sulfur, right? Its color is yellow. The pizza in this case, the substance of pizza, has a nice smell if you like pizza. You might also include things like its rigidity. Okay, so maybe you'd look at your, glass, or you'd look at something like that and say, well, it's really rigid, it's hard. Something might be brittle. There's other physical properties that we can measure in the lab. Okay, so we can describe the temperature at which a substance boils or melts. Okay, it's called its boiling point, right? We can talk about something's thickness or resistance to flow. That would be its viscosity. Okay, so you could think about syrup, how slow it flows. All right, that would have a different viscosity than water. So we can measure these physical properties. These are all examples of physical properties. Okay, so you could think of all these examples, and physical changes then, okay, are changes that alter the physical form of a material without changing its chemical identity. Okay, so this is something that is really important for us to remember, okay, throughout this chapter. That is a terrible asterisk. Let me fix that, okay? So this is something that we need to remember. That one's a little better, I guess, but definitely remember this. Changes that alter the physical form of matter without changing its chemical identity are physical changes, okay? So here's a few examples. When you melt ice, okay, in the last video we were talking about states of matter. So in this video, we melt some ice, okay? We didn't change chemical identity. Okay, so did not change that. Oh my goodness. Okay, hold on. Bear with me. Doesn't want to get rid of that guy. Don't know why. Chemical. And oh my goodness. And T. Okay. So you melted the ice, you didn't change its chemical identity. That is the key. It's still water before you melted it. If we put it back in the freezer, we'd get ice back. So it is still water, both in the solid state and in the liquid state in this case. Okay, here's another one. Dissolving sugar in water. Okay, so you take some sugar, you put it in water. In this picture, it's a little more obvious. It's the one with sugar dissolved in it is like a grayish color, but if you were to do this right now, go in your kitchen and take some sugar packets or whatever you have and dissolve it in water, you probably wouldn't actually see a difference. It looked like the sugar is gone when you looked at the water. But even though the sugar seems to have disappeared, the sugar is still there, right? You taste the water, it tastes sweet. And if you were to boil off all the water, you'd be left with sugar, okay? So this is a physical change, all right? These are physical changes. Another way we can think about it is that, oh my goodness, this is giving me fits. Molecules are unchanged. Okay, nothing happened with the chemical identity of the sugar molecules or the water molecules in either of these examples. Okay, you can recover the sugar again by evaporating the water. So in a physical change, the particles are not broken or changed in any way. All right, that's another way if you want to write that down. That's another way of what I just said here, molecules are unchanged. And I'll say it again. In a physical change, the particles are not broken or changed in any way. So that's something that we need to keep in mind here. Now, a chemical change, on the other hand, occurs when the chemical identity of a substance is destroyed, okay? And a new substance forms. So this would be something that we would call, and that we will learn about as we go through this class, a chemical reaction, all right? You started with one type of thing, you ended with another type of thing, and there's really no going back. You destroyed the identity of the original compound, all right? So this is a chemical reaction, very important, okay? So well, actually, before I say what I was just about to say, here's an example of a chemical reaction or a chemical change, all right? If you are anything like me, sometimes this happens to you, okay? You put some toast in there. You know, I may put some toast in the toaster oven in the morning for me and my wife. And what is that smell that I smell? Oh, I'm burning the toast, okay? And try as I may to scrape off the burnt bits of the toast and hope that my wife doesn't notice. You cannot change the burnt piece of toast back to unburnt bread. Okay, it is burnt. You need to get some more bread out of the pantry and put it in the toaster oven. I think we've all experienced something like this before. Maybe even with sugar. Let's say you put some sugar on the stove, you're trying to make caramel, and you walk away for a second and it's a disaster. Okay, so burning something is a chemical change. Okay, there's a chemical reaction going on here. And one of the things that is a key that we need to understand or recognize, okay, is that, let me say this before I say what I was just about to say. So chemical properties are all the chemical changes possible for a substance, right? So, excuse me, chemical properties are all the, chemical changes possible for a substance. I think that's what I just said, but I thought I said it wrong the first time. Okay, so I'll say it one more time. Something's chemical properties is all of the chemical changes possible for a substance. And we'll talk about that a little bit more as we go through. Now, here's the key. One or more of our five senses can usually detect chemical changes. So a color change often indicates a chemical change, as in the case when you burn some toast, right? So the change of the toast, the change of the bread in its color indicates a chemical reaction has occurred. A change in smell of something, a change in, if an explosion goes off, the sound that's given off. All of these things are sometimes, I'd say most of our examples will see examples of chemical changes. Other examples that I have written down here, the feeling that we get from the heat that's coming off of a match when we strike a match, okay? That's an example of a chemical change going on. The smell and taste of bad milk, which I I didn't realize we had some milk that was bad, and I tried to eat some cereal with some bad milk. It was awful. All right, I can definitely say the taste, bad, smell, definitely smelt it afterwards bad, okay? So again, these are all examples of a chemical change has happened. The substance has changed. All right, so as we go through and look at different examples, then we should be on the lookout for if there's something changing, like a color change or a change in taste, change in smell of the substance, whatever it might be. And that's a good indication, that a chemical change has probably already occurred. Okay, so this is just a summary of basically what I've just been saying. And let's see here, I'm looking at my notes here, and I think okay, we're good. I confused my notes a little bit, but here's a table of what I was just saying. In a chemical change, the old substance is destroyed, a new substance is formed, right? Physical change, no new substance is formed. We just, the old substance changes its form, okay? Meaning like you go from a solid ice cube to liquid water, but it's still water in both cases. The properties here, chemical properties are defined by all the possible chemical changes a substance can undergo. Okay, and then physical properties are things like color, shape, odor, hardness, density, boiling point, melting point, viscosity. Those are physical properties of material. So when you change materials with a chemical change, you're going to most likely change its physical properties. Okay, so let's look at a few examples here. So let's classify each of the following as a chemical or a physical change, and then we'll end this video, I believe. Yes. So the first one, the condensation of water vapor. Well, I'll say this. It's not changing its identity, right? It's still water before and after, right? It's just condensing on maybe your glasses, right? When you come in from, it's hot outside and you come inside to the air conditioning and they fog up. So I'll just say this is a physical change, it's still water. The formation of polyethylene from ethylene. Well, it's kind of given away in the name here. Ethylene isn't polyethylene, even if you don't know what those things look like or you don't know their structure. Their names are different, right? We're not changing to a different form of ethylene. We're changing to a new compound. So this would be a chemical change. All right, so I'm actually going to let you, why don't you pause the video right now if you're following along with the PowerPoints or in your notes in class, and why don't you try to do the rest of them, okay? And then I'll put up the answers and go through them quickly. So pause the video, see if you can answer these on your own. Okay, so I'm assuming that you may have paused the video there and that you have the answers. So let's go through this. So the rusting of iron, well, the iron, right, it's changing color, one. If you've seen rust, you know you can't really, and worked with rust, you know you can't really get the iron back. So this is a chemical change. Melting of lead, well, it's lead before and after it melted. Melting is a physical change in the material. So this is physical. Dissolving sugar in water, well, we already talked about that. That's a physical change. Tarnishing of silver, if you look that up, if you were confused about that, the silver is changing color. So a change in color is an example of a chemical change. And then crushing a stone, obviously it's maybe smaller pieces of stone, but it's still stone, excuse me. Okay, so those are the answers to this short little example. And in our next video, we're going to be talking about pure substances and mixtures.